I just wanted to mention another feature that the SunSynk inverters have. I think someone commented, or I was supposed to do something about doing this test a little while ago, but essentially what it is on the load, on the generator connection, it is actually, although it's labelled generator, it's an auxiliary, so it can be configured for an input or an output. So this is using the AC coupling feature through that auxiliary input with a solar system. So imagine this is a beastly solar system. It can be whatever. It's just a grid-tied system, and it's fed into the auxiliary contact there, which is labelled generator. So what you do is you set the inverter up, just to auxiliary, set it for a microgrid inverter, and then your voltages. So what's happening is, it's a really nice British summer's day, so we've got a massive 29 watts going from a 400 watt panel through this little inverter into the batteries, but never mind. So it's coming from the inverter into the auxiliary port, and then it's being charged. Now, one thing which is really great is if you do lose AC power like this, although for a second the AC coupled system will shut down, it will then fire back up. So that's really good because it works in an off-grid state. But a lot of time you can't actually wire the existing PV directly into this because it's somewhere else along the line. It's connected to the grid on your backup or something. Something telling me it's off grid. So what you have to do is, if you did still want to your batteries to charge up when the grid goes down, you can connect your AC grid-tied system on the essential load side, and it will still work. But the problem you will get is once the batteries reach full charge voltage, when it reaches full charge voltage, then there is no way for the inverter to switch off the AC coupled solar. So what will happen is it will go to full charge, and the inverter will go into over voltage error, and it will shut down. The best thing about using the auxiliary generator port is it can just frequency shift, or it can just turn that port off once the batteries are fully charged. But it's a luxury to be able to connect your existing solar or someone's existing solar directly into that port. So one thing you can do is, if you have a voltage sensing relay connected to, again, don't judge me, if you had it connected to your battery system, this is just a very temporary thing. Yeah, we won't go into that. If you had it connected to your battery to a voltage sensing relay, and you could set that so the relay either, I don't know, disconnected once it reached a certain voltage, then what you would do is a cable between that relay and your existing PV would need to be run, and you would just install your existing PV via a normally closed, actually probably a normally open contact, because when the power went down you'd want it to disconnect. But so then essentially when the relay connects here over at your AC solar, it disconnects, and then that would be one way to be able to still have your existing PV contributing, your existing AC coupled PV contributing to your off-grid system, or when there is a power cut, or to your off-grid system, and for it to be able to function safely. The other thing which would be a bit difficult to do as well would be, if your existing PV system is massive, if it's a large system, you would need to either have a high-powered SunSynk which can handle the maximum generation of that system, or you'd have to set a generation limit. on that system when it is an off-grid mode. So for instance, I think this 5.5 can charge at, I don't know, let's say 125 amps, 120 amps maximum. So you wouldn't want your existing PV to generate more than 5.5 kilowatts in the off-grid mode, because it would put an overload on the, well, kind of like an overfeed, but it would come up as an overload error on the inverter. So you would need to make sure that the generation would be lower than the maximum charge current of the inverter. Anyway, I hope that's helpful for someone.